Here we go, guys, our last section. So looking at key features of piecewise functions. All right, so the key features are the same thing as our previous key features problems. The only difference is that instead of having endpoints that are arrows, we have endpoints that are dots. All right, so we're going to practice with that a little bit. The other thing is right here. There's a gap in our function. Alrighty, so let's start with our domain. So the domain is all of the x values in our function. So you can see right here it's continuous. And then there's a gap right here. So this little gap that you see here is not within our domain. And then we have another piece of domain. All right, so just describing these x values. For this first segment, it starts here on the left at -7. And notice that the endpoint here is an open circle. That's called exclusive. So when I put the -7, I'm using the exclusive parenthesis. So then I follow this segment all the way to the end of that segment. And right here at x equals 0, this segment stops with a closed endpoint. So this is inclusive. All right. So I'm going to put a 0 and a square bracket. Now this little line here was not all of my function. I also have this parabola right here. So I need to include that in my domain. So the very left part of this parabola is at 1. And notice it has the open endpoint here, which is exclusive. So I put a curve. And if I follow my parabola, the rightmost boundary is right here at 6. And it has the filled in endpoint, which is inclusive. So when I put that 6, I put the square bracket. So now I'm going to do the range. All right, so I'm following my y values. All right, it looks like my lowest y value is right here at -3. So now we have to decide whether it's inclusive or exclusive. Here we have exclusive, but here where it's part of the curve, this is inclusive. So we include it because right here exists. All right, so at -3, he gets a square bracket because the curve counts as inclusion. All right, it has a value here. All right, so then I'm going up, 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 looking for my highest number. And my highest number on my graph here is at 4. Notice with the filled in dot. So because that endpoint is filled in, that 4 will be inclusive. Now, we have addressed the very lowest part of the graph and the very highest part of the graph. And there aren't any gaps that are missing, right? See how I'm dragging my line along the graph here? And it's not hitting any open air. Whereas when I was doing the domain, right, I crossed this section with my vertical line and there was a hole. So this way, when I'm considering my y values, there's no hole. So I only use the one interval. Alrighty, so now this is asking me for the x-intercept. This one actually has 3 x-intercepts. Here, here, and here. Now, some of these intercepts are nice. I think this one's at 5, maybe. This one's a little hard to tell. It's just shy of 2. So we're going to use our best judgment there. And this one's obviously at -5. All right, so my x-intercepts. I already have x-intercept. This far left one is at -5, 0. My next one, just shy of 2, I think that's at 1.5-ish. And then my third one is at 5, 0. Now notice I wrote those as ordered pairs, and I separated the ordered pairs by commas. When you take your test, read the instructions about how they want you to list those numbers. Sometimes they're okay with you just saying the numbers, -5, 1.55. So just kind of watch yourself there. Now when I look at this graph, the y-intercept So the point that's along this line, there's only one y-intercept, and it's right here at 4. So that is the ordered pair 0, 4. All right, so the next thing we need to do is find our positive intervals. All right, so remember with the positive intervals, I'm looking for the parts of the graph that are above the x-axis. All right, so this part of the graph is above the x-axis, and then there's kind of a hole there, right? And then, ugh, this part's kind of ugly to color because it's not all the way to the line. So don't get too color happy with your intercept. All right, so then that segment is also positive. And then right here is also positive. So when I go to describe my positive intercepts, I'm going to describe 3 separate intervals because there's 3 parts that I colored that are above the y-axis. Alrighty, so if I'm looking at those, first I have this piece. Alright, now right here at -4, it's neither positive nor negative because it's on the axis here. So my -4 is going to be exclusive because it's neither positive nor negative. But this right-hand boundary of that has the shaded dot on it and is still a positive number. It's not 0. So this is inclusive at 0 because we're using the x values, -4, 0. So now I have this little strip here, all right? Remember, this is at 1, and we said this is about 1.5, so just a little tiny piece. All right, now this endpoint that's on the left-hand boundary is hollow. That means we are using the exclusive parenthesis. I'm also using the exclusive parenthesis here on the right-hand side because at 0, it is neither positive nor negative. Alrighty, almost done, guys. So then here at 5, right, our y value is 0, which is neither positive nor negative. So we're going to use our exclusive notation. And then I realized I made a mistake with my shading. This graph doesn't continue on for forever, does it? It's just that little squeaky piece right there. Sorry, y'all. So again, I'm erasing this because it didn't go on for forever. It just was that piece. And so the right-hand boundary of that piece is at 6. And notice the endpoint of that is inclusive. It has the filled in piece. So at 6, I'm going to include it by using the square bracket. So now we're going to do the same thing with the negative intervals, and I'm going to color those in red. So I'm looking for the pieces of the graph that are underneath the x-axis. So the first piece I see underneath the x-axis is this section here in red. All right, and then the next piece I see is this one right here. So because there's 2 pieces of the graph that I'm coloring in red, that means that I'm going to have 2 intervals that are negative. All right? So starting here on the left-hand boundary is at -7, and it has an open circle. So I'm going to use the exclusive notation by putting the curved parenthesis. Now, if I go to the right-hand boundary of this red section, it's on the 0, and 0 is neither positive nor negative, so I don't include that -4 there. And so then this piece here, this part is at 1.5, and again, that's at a 0, which will be exclusive. And then here at 5 is also exclusive because it's also at a 0. So I'm going to say, comma, 1.5, 5. And notice I separated my intervals with a comma. Alrighty, so now we're going to talk about increasing. So remember, increasing means to go uphill. So I'm looking for the pieces of my graph that are going uphill as I go from left to right. So if I start at this endpoint, you could see this section that I shaded in green is all going uphill. I am also going uphill from this piece on. And I actually want to make that an open circle right there, because it's neither increasing nor decreasing right there. All right, so looking at this green section, okay? So here on the left, it goes from negative 7 to 4, or sorry, to 0. Don't use the 4, use the 0 because we're counting x values, okay? So from negative 7 to 0. Now at negative 7, you have that hollow endpoint, so you're going to use the exclusive notation. But at 0, you have the filled in endpoint, so you use the inclusive with the square bracket. Now looking here at this piece, at the very tip of this parabola, which is at like 3.5-ish, this is neither increasing nor decreasing. It's a turning point. It's changing directions. So I'm not going to include that. I'm treating it as if there's a hollow circle here. All right, so I have 3.5, and then the right-hand boundary of the green is 6. And that 6 has the filled in point, so I am using the inclusive notation there. We're almost done, guys. Alrighty, so then decreasing intervals, right? I'm starting at this yellow circle-y thingy, and I'm going down here. And again, because it has a turning point at the bottom there, I'm going to treat this yellow piece as excluded because it's changing points there, or changing direction there. Alrighty, so from 1 to 3.5, it is decreasing. And I'm using the curved brackets on both of those because neither of them is included. Alrighty, friends, we have one last piece. And the last piece is the average rate of change, which we taught you guys to just call slope, not mope, slope, which is an M. Alright, so from 0 to 4, 0 is here, and 4 is here. Alright, oh, I shouldn't have used 0 to 4 because it's not continuous. I'm going to change this, pretend that's a 1 there, okay? So from 1 to 4. So 1 is right here, and 4 is right here. Alrighty, so we could actually use our rise over run just to count it, okay? What we are actually finding the slope of is the section of line that would connect those in our heads. Alright, so if I'm doing rise over run, this is actually fall over run, so I'm going to have a negative slope, so I'm putting a minus here. And from this dot at 3 to this dot at negative 3, it's falling by 6. Then if I think about my run, all right, I have it here at 1 to 4. So from 1 to 4 is 3. And then lastly, you just reduce your fraction. So negative 6/3 is the same thing as negative 2. And that's your average rate of change. All right, and it's just counting the boxes, rise over run, to find that slope. And there we have it, y'all. Good luck on your test.